You rock metal. I'm gonna get a noise complaint. So I don't have anything to copyright for the intro teams. And I'm finally home, where taxes are high and it smells like smoke everywhere. So anyways, please just read the problem yourself. Oh, the floor goes on, people gonna die. Oh no! Let's go on So anyways, the givens are that the diameter is 5 meters, and you know half the diameter is the radius, so and that's what we need. So half of 5 is 2.5. So and minimum is 30 kilograms. Remember, kilograms the SI unit. But then we have two friction coefficients. Static friction coefficient goes from 0.6 to 1.0. Remember, this is interval notation that you use in calculus a lot. And the kinetic friction force would range from 0.4 to 0.7. and then the three equations that you would use is the force equals mass times acceleration. And also you can later on you would plug in a for
son of a gun
to velocity squared divided by the radius.
Coronavirus! Coronavirus!
But then since this is a circular motion and we are looking for the angular velocity, we need an equation for angular velocity. So later on you would need to plug in for v, which is omega times r, omega being the angular speed. So anyways, we have to label the forces that's keeping that would keep the riders afloat. So the surface is the cylinder where the people are lying down on basically. So that means the normal force is going right, and it's equal to mass times acceleration. Um, friction force that is static friction more specifically is keeping the people on the ride without falling, assuming that they don't fall. And in order for that, it has to be bigger than the mass times gravitational acceleration. So yeah. But the minimum angular speed we're gonna need that friction is gonna be static friction is gonna be bigger than mass times gravitational force. So as you can see, let's get the horizontal first, because again, friction needs normal force. So we set normal force equal to mass times acceleration, um, and uh, and since it's going in a circle, there's centripetal acceleration. Um, so we can plug in v squared over r for a, and this is what we get. But then we're looking for angular velocity. This is tangential velocity. So tangential velocity equals omega times r. So plug that in for b, and then the r's cancel out. So you get the mass times angular velocity squared times the radius. Now we plug the normal force in for static friction. We can just leave it like that because it's best to just isolate the omega by itself. So in order to isolate omega to make this easier, we plug in all this conglomeration to normal force, and then you get mass times omega squared times r, and then to isolate omega we have to divide both sides by static mu times mass times r, so that they will go on the right side, and they will leave omega squared by itself. But then to truly isolate angular velocity, you have to get the square root of both sides, and then and then there you go. That's how you isolate omega for the answer. I forgot to mention to keep the minimum velocity required to keep the people staying on there is if static friction is equal or greater than mass times gravitational acceleration. So you have to plug in mass times gravitational acceleration here. So the masses cancel out, and now you plug in numbers. G is 9.81 meters per second squared, and uh, and to get the maximum friction in order to use the minimum angular velocity, it's 1. So, and then the radius is 2.5, and then if you get this answer, then you get 3.924, and then you square root that, and then you get 1.9 radians per second. So that is my answer for this question. You guys might get different answers. But anyways, see you in the next video. Don't forget to drop the dislike.